Hello, last time we saw that Fermi-Dirac statistics is required for the explaining the distribution of electrons in the case of metals or semiconductors. We saw that there are three important functions involved in Fermi-Dirac statistics. So one of them is the Fermi factor f of e, which is given by 1 by 1 plus e power of e minus ef by kt. So here we see that this is actually the probability function which gives us the probability that a given energy level E is occupied, and we see that this function depends upon the energy level E itself, and also it depends upon the temperature T. Therefore, now I am going to talk about the probability distribution over different energy levels and also at different temperature. So let us take the first case. Case 1, when the temperature is 0 Kelvin, the lowest temperature of minus 273 degree centigrade. So in this case again I will take a sub case for energy levels E, which is above the Fermi level, that is E greater than EF. Now I will see what will happen to the Fermi factor f of e function. So in this I will take this term E minus EF by kt. So E minus EF by kt, now if you substitute this value of E greater than EF, we get this equal to positive value divided by denominator 0. That means we get plus infinity. So therefore f of E becomes 1 by 1 plus e power of plus infinity, which is infinity. Therefore we get 1 by 1 plus infinity, which is 0. That means f of E, the probability value becomes 0. What it means is that you cannot find any electron in the energy level above Fermi level at the temperature of 0 Kelvin. Now let us take the another case for energy levels which are below the Fermi level, that is E less than EF. Now what happens to this term E minus EF by kt? So we get here negative value by 0. That means we get minus infinity. Therefore f of E becomes equal to 1 by 1 plus e power of minus infinity. That means e power of minus infinity is 0. Therefore you get 1 by 1, that is 1. That means probability is equal to 1. That means we see that all energy levels which are below the Fermi level are completely occupied. That means the probability is 100%. This is true at the temperature of 0 Kelvin. Now if we suppose take the temperature of the metal above the 0 Kelvin, so what will happen to the probability distribution function? So let us take the second case now. The temperature is greater than 0 Kelvin. Again here I will take sub cases when E is very greater than EF. That means I am taking the energy levels which are far above the Fermi level, very much above the Fermi level. If we take those levels, we again see that this term E minus EF by kt, that becomes equal to plus infinity in this case. Therefore we get f of E is equal to 1 by 1 plus e power of plus infinity, which is equal to 0. That means the probability of finding the electron in the energy levels far above the Fermi level is 0. That means those levels will be empty. Now if we take when E is very less than Fermi level, that means you are taking the energy levels which are far below the Fermi level, then we get f of E is equal to 1 by 1 plus e power of minus infinity, because E minus EF by kt again becomes minus infinity. That means this is 0. That means we get f of E is equal to 1. Again we see here that the energy levels which are very much below Fermi level, they are completely occupied, 100% occupied. Now let us take the intermediate energy level, that is when E is equal to the Fermi level EF. When E is equal to EF, E minus EF by kt becomes equal to 0. That means we get f of E is equal to 1 by 1 plus e power of 0. E power of 0 is 1. Therefore we get 1 by 1 plus 1, which is 1 by 2 or 50%, 0.5 or 50%. That means the Fermi energy level is having the probability of 50% of being occupied. So whatever we got so far is summarized here in this graph here. This graph is graph of f of E, the probability function versus the energy level. So probability values are lying between 0 to 1. The energy levels starting from the bottom of the valence band 0 to Fermi level EF and above the Fermi level. So we saw that at temperature 0 Kelvin, probability is all 1 below the Fermi level, and above the Fermi level it is all 0. So this is the curve we get for temperature 0 Kelvin. Suppose now the temperature is greater than 0 Kelvin, we see that for energy levels very much below Fermi level, probability is 1, and energy levels very much above Fermi level, probability is 0. So it becomes 0.5 at the energy level equal to Fermi level. So here we see that the probability will slowly gradually decrease from 1 to 0.5 when you come from energy levels below Fermi level towards Fermi level. And here also above the Fermi level it is 0 here for higher energy levels, but as we come closer to Fermi level, the probability value gradually increases from 0 to 0.5. So this is the change we get in the probability distribution curve when the temperature is raised above the 0 Kelvin. So what is the meaning of this is, when the temperature is increased, the electrons which are closer to the Fermi level, they absorb the energy and go over from energy levels below Fermi level to energy levels above Fermi level.